I'm Matt Godbolt.
And I'm Ben Rady.
And this is Two's Complement, a programming podcast. Hey Ben.
Hey Matt.
How's it going?
Pretty great.
Awesome. Well, I was chatting to someone, the other day, and they were asking how much preparation work we do before we record these podcasts. Mm-hmm. And they were pleasantly surprised to learn that we don't do an awful lot. We're not scripted in any meaningful way. I mean, you and I have a couple of minutes chat beforehand, and then we decide on a topic, and then we just basically hit record. So we're really putting that to the test today, because we literally said, hey, let's talk about linting. And then we've hit record. So, let's talk about linting. What's linting, Ben?
That is the extent of the prep. What is linting? Linting is what you do when you don't have a compiler. And that's one way to think about it.
That's an interesting point. Although I would say that I use as much linting in compiled languages as I do in non-compiled languages. So it's equally. But lint. I mean, so I don't even know. I've never really stopped to think about the etymology, but like lint is like
the entomology.
No, the insect collectology of.
That's gonna have to be a running bit. It's like less and fewer. We just have to constantly confuse entomology. And entomology. Yes. One day we're going to have to talk about insects and find a way to work that in. I was going to say, what's
the etymology of the word bug in computing?
Yes. Right. Uh-huh.
Whoa! Oh, man.
Yeah.
So, but lint is like the stuff that you find at the bottom of your pocket after you've worn a pair of trousers for a while, and you go, what is all of this nonsense? And bits of fluff and whatnot. And presumably linting, the code term, comes from like the removal of that. Like, let's get rid of all that fluff. Let's clean it up. Let's get the little brush out. But I
guess I honestly don't know what that's from.
I don't know where it comes from, but what I think of it as is essentially static analysis of code and the application of relatively straightforward rules to say, no, this is how the code ought to be. Right, the language probably gives you freedom to do things in lots of different ways, and as a sort of choice, you say these ways are the ways that we're doing this thing. Whenever we call our log methods, we don't use Python f strings, and I say this, and you're going to grin at me because this is my personal bugbear, because that's not the logger automatically does some of the formatting for you, and if you don't use the loggers facility, you're paying a cost for something that's going to happen anyway. So, and you can say, well, that's straightforward. Let's write a rule for it, and then I can apply it automatically to my code. But there's thousands of other things, right? So it's basically code quality checking. And then you said something about compilers. Do you want to elaborate on why compilers or the lack of?
So if you don't have a compiler and all of your code is interpreted, then there's never an opportunity to do this kind of static checking. Naturally, but if your code is compiled, you could make the argument in any compiled language that a linter is just all the things the compiler team didn't have time to add warnings for.
Well,
right?
There's that, but there's also a lot of opinionated things that they may or may not want to add as a general principle, right? There's definitely things that are known to be okay, but maybe frowned upon, and it's maybe not the compiler's place to make that decision on behalf of you. And some of this stuff also comes from the fact that if you're writing in a compiled language that has stronger types, then you can make some of the sort of policy decisions about how things may or may not be used by saying, well, I don't accept anything other than this type here, and then the compiler enforces your rules. You get to write the rules using the language. But in, say, an interpreted language, we'll pick on Python, you don't get the opportunity to make those distinctions. You have to sort of say, no, this is I need something else to uphold these rules that I'm making. But
yeah, definitely. I mean, if you don't have the compiler there, then I think the linter has a much more. I'm not really trying to make the argument that if you have a compiled language, you don't need a linter. That's not what I'm saying. But I am saying that if you don't have a compiled language, there are going to be more instances where you need a linter because there's just no other opportunity to do that. And I feel like that demand changes with various aspects of a team, like how junior the people are, how big the team is. how much consensus there is around sort of like conventions that prevent bugs or enforce a particular style, or just ensure that a pattern is repeated consistently and things like that. I think it's actually quite common to have situations where if you got everybody in a room to try to have them agree on how something should be, they would actually agree. Maybe after a little bit of a discussion, but they would agree, but they don't know that they agree. So you sort of like have the linter there as the objective judge, be like, no, we pre-agreed that we're agreeing on this. So if the linter's telling you something, then that's what we're doing. And then everyone's like, well, okay, seems reasonable, right?
Right.
So there's sort of like varying degrees to which you might agree, but I think that can be a role that linters play is if you have larger teams especially, but really any situation where you're trying to create that consensus around like what should the code be doing, what it should not be doing. Linters are a tool to achieve that.
And I suppose the way that you could think about it is that we have tests for the functionality of our code, and we make them automated, and we have them like checked in, and they're run as part of a CI.
Yep.
What linting is a level above that, like meta. This is how we said we're going to write the code. How do we enforce and check? How do we check that we are keeping to the rules that we all agreed on? And So I think probably the difficult aspect about linting is it is more subjective. There are things that are more subjective, and you have to make some. You alluded to some that you get most people in a room and they say, don't do X, and I'm having trouble thinking about what an X is that would everyone would agree to not.
Well, the non-scalar values in Python default arguments I think is a great one, and it is actually like one of the ones where it's like I don't actually think it's maybe as clear as like the tests are testing for like correctness and behavior, and the lints are more stylistic, because you can definitely find bugs in code with linters. Like
we should just explain a little bit.
It is possible to do this. Oh yeah,
what that is, because
the
if
one
anyone's
in particular one.
Yeah. So do you want to give us a quick rundown?
Yeah, I think I can do it off the top of my head. So basically, when you declare like a function or a method in Python, you can give it default arguments. And
so like arguments can have parameters that you're passing will have default values. So you can say like def say hello username equals Matt, and which means if you call it with no args, it'll say Matt, and if you call it with an arg, it'll say what you passed in. So you get to default the parameters that you're passing into a function. Got it.
Yes. And so the problem is that Python has no opinions at all about what those values can actually be. They can be anything.
Right.
And very unintuitively, I think, if you pass in something like a dictionary or a list, the declaration of that, the creation of that object is done once when the function is evaluated, not when it's executed. So every subsequent execution of that function will reuse the same instance of a list or a dictionary over and over again.
Everything that's not a scalar type, like an integer or a float or a string, is a reference to an object that exists, and so there is exactly one object that is the like empty dictionary you pass as the default.
Exactly.
And now, of course, if you mutate that, you're mutating the actual thing that's going to be passed in every single time. I see.
Right.
And so that seems like that's a language flaw. That seems like that's actually a problem with the language.
Well, and that's why I kind of make a little bit. I mean, it's very tongue-in-cheek, but I make the argument, with compilers and stuff, that like the lints are just all the things the compiler team didn't get around to making warnings about, which is not. It's not really true. It's just
but it carries some of the flavor.
There's some flavor of it. Yeah. So.
So that's an example of a lint rule that everyone who gets into a room would agree with, right? Would say like, this is all. There is almost no situation in which you want this to be true. And I mean, I suppose the other thing is that with linting rules, you can reasonably decide to turn them off on a per line basis, which is something you normally don't do for other things. Like in an actual compiler, it's like there is no way to get past the fact that the compiler is saying this is broken. Your types are not compatible. You tried to pass them in, but here you can say like, no, just on this line, don't do it. But it's an opt-in thing to do, and maybe you even turn those off, maybe if you decide. But like, if you did really, really, really mean to have a mutable default parameter because maybe you're accumulating things into it or whatever you're doing, but it's very purposefully done, then you can turn it off. But it's not the default anymore, and it stops you from, it protects you from yourself down the line, right?
Yeah.
So that's an interesting, that's a lint rule that everyone can get behind, but I'm sure there are examples of rules that people could reasonably disagree about.
Oh yeah, I mean, a lot of times I feel like you'll have linters that have stylistic rules, like, oh, this variable name is too short, right? That's a linting rule,
right?
And like, okay, like, I get that people would want to do that, but you're almost certainly going to run into situations where it's like, no, in this context,
it's fine to have X and Y.
It's fine to have X.
Those are what we call the parameters that get passed into, I don't know,
a
plotting
the graphing
library
that's plotting X and Y, and like that's actually what they are.
And you
right?
have to be very careful that you're not incentivizing people to start adding like X _ version _ 1 just to make it long enough, right?
Yeah, right.
It's a sort of anti-pattern there. But yeah, there's, I mean, I suppose an extension of linting rules, and maybe this is, actually, I don't know if you would agree with this. How do you think about automatic code formatting as essentially a lint? Or rather, the checking of a format could be considered to be a lint. It's like, hey, if your code doesn't look the way that we said our code is going to look, then it's you're breaking the sort of the style guide. And we value consistency in layout so that we don't spend our time like parsing and recognizing, oh no, that's just a function declaration or whatever, but you did it in a different way from me, or however it's done.
Yeah, absolutely. Yeah, my take on that is that you should use a consistent style like 100% of the time. It is possible to do that without something to enforce it if you have a small enough and cohesive enough team, and I have been on teams like that where it's just like, yeah, we're just going to do it right. And that's fine, but no matter if it takes automatic formatting and if it takes checking of that automatic formatting to make sure that you are doing it, then that's what you should do. It's sort of like, if you were to model this over the evolution of a team, you start off with just like 2 engineers who are very senior and know each other well. It's just like, we're using that formatting that we always use, right? Yes, that's what we're doing.
Right.
Great. And then you work for 6 months and you add 2 more people to the team, and you start to notice as you open up files that the formatting isn't quite right. And you tell them like, hey guys, you need to make sure that your formatting is up to date. They go, oh yeah, sorry. And then maybe it gets a little better. And then you add 2 more people to the team and everything goes out the window. You're like, that's it. We're putting in automatic formatting. Right. I can't do this anymore. Right?
I think, but then there's a level above that, which we're grinning at each other because I think we agree on this, that senior or otherwise experienced, I think is probably a nicer way to put it, enough where I'm like, no, day one, in comes the automatic formatting. It's just, I don't want to have to argue about this. I don't even agree often with the way that the code ends up looking, but I value the consistency and the simplicity and frankly things like, so I'm talking specifically in like a C++ code base, I will use Clang format, which is now pretty much across the board accepted by all editors, and it's an external tool that just works. And it's configurable enough. It's got many bells and whistles, and you can usually find a decent enough compromise. And then you check in your format file, and you say like, "That's just how our code's going to look now." And you can turn it off in small regions if you really, really, really want to like have like a data structure that has a sequence of hex numbers or something. You're like, no, these are 8 a line and whatever. But for the vast majority of time, you just want to say this is our code style. And what I have found is that the consistency is great. And it allows me to do refactorings in my code base without having to worry about all those other funny little rules where, if you did a find and replace and you replace a name with a slightly shorter name, and you have like rules about things either aligning or not aligning or fitting on a line or not fitting a line. We've all gone back to code bases where you can clearly see things don't line up anymore because somebody renamed something. And it's like, it's all shifted. And that just goes away. And that's a kind of a nice property, especially with IDEs that can do refactoring and that also understand the format file, because they're like, I'll do the refactor and I'll do it in the style as described by the formatting you've got. So that's very valuable to me. And final thing on that as well is that it tends to make diffs between like long-lived branches less painful, as you will know that like if you have arrived at this, if you've like separated from the baseline, the main line, and you've been effectively applying small changes that are equivalent, you'll run the formatter in both sides and you'll basically agree on everything except for the parts where you're actually different, and that's fine. And then you can like merge them back in together. And so yeah, I'm a big fan of that. But I just wasn't sure whether or not you consider this to be a linter. I mean, here I am like testing to see whether or not the thing that I'm talking about matches our very important, as discussed, carefully decided topic for today.
Yeah, right. Exactly.
Oh my God, am I going off topic or ticket?
No, and I would say anytime you can get automatic formatting in a consistent way, it's less things you have to worry about, right? Fewer. You don't have to like spend any brain cycles at all thinking about the formatting. The one place where I think it gets weird though is if you have an IDE that does automatic formatting, and and then I think this is becoming less and less true, but I think there are still situations where this might be true, where the formatting operation cannot be externalized, right? So basically, in order to enforce the format, you have to have the IDE running. Like, you can't enforce it in a build, or you can't use a different editor and have a command line tool that does it. Like, whatever you choose to do your formatting and to check your formatting needs to have a like character for character equivalent that can be run automatically, that can be run from the command line, can be run in different tools
on the CI system to make sure that you have a conform. All of these things,
exactly.
I wholeheartedly agree. I think that's one of the big deals. I think when a lot of the JetBrains IDEs have always had their own idea about formatting, and for the longest time I just used their defaults. But they are moving now more and more to where they're like, well, here's the .config file that tells me how to format, and I'll use that instead. That's great, brilliant. Don't use your own formatter. Use one that my friends who are using VI or Edlin or whatever they're using.
It's just like tooling. You have to have intersubjective tooling. You have to have tooling that everyone and everything, like every part of your process, can use to produce the same result, right? They can follow the same steps and produce the same result. Because if you don't, it's just going to create a whole bunch of headache that you don't need.
Right. I think what you've kind of implied in that also is that those one way to achieve intersubjectivity is to just mandate these are the exact tools everyone must use. Right. So I could just say, hey, everyone uses this tool, this editor.
Yes.
But
we're all using PyCharm, we're all using CLion, we're all using IntelliJ IDEA, right?
Yeah,
like,
or
that's one
Visual
way
Studio Code or VI with these. Yeah, that's one way of doing it. But I think you and I have realized that that's a great recipe to make unhappy developers. There's like the one thing you can do to a developer to make them feel not effective in their own, not able to make the changes at the speed they would otherwise be able to do, is to make them use an editor they're not familiar with.
It's like wearing someone else's clothes. No one likes doing that.
I mean, it's a funny thing. I mean, this is sort of slightly different, I know, but I always used to think it was funny that people would buy expensive keyboards to work on. Mm-hmm. Until I bought one myself and went, oh my gosh, my life is a ton better now. Mm-hmm. I don't have pains in my hands. I got like all those good things, and I feel like I'm more effective in my job. And then it occurred to me, it's like that's the primary way I communicate to do my job is through typing. Yep. And so I should spend, if I'm going to spend any money on anything, I should spend it on a decent keyboard, a decent mouse, have a decent editor that I'm happy with, so that I can do my craft as effectively as I can in the way that I am happy with. And I've kind of got over that hump now, that's not like, oh, I should just be able to pick up any old thing and get on with it. It's like you don't see musicians wandering around just picking up any old, cello and kind of going, oh, this will do, I suppose. I mean, I'm sure they can. A good musician will be able to make good music out of anything, but you wouldn't expect them to. And I'm not saying that that's what I was thinking, but it was an epiphany moment I have, and it's certainly how I'm justifying, hundreds of dollars worth of keyboards to myself.
Yeah. No, and I mean, you will definitely have a hard time hiring if you're like, we use this IDE and this tool chain.
Very good point.
And, only MacBooks and all the other constraints that you put on there. It's like you better be putting them on there for a good reason, because you're eliminating a whole pool of potentially really good engineers that will not work at your company because they can't use VI or whatever.
Right. Yeah. No, that's an interesting thing. I mean, so anyway, going back to it, this is obviously us saying that any kind of linting tools or formatting tools need to be intersubjective, and the obvious way to say that they need to be able to run headless on a CI server, if nothing else, right? If only that alone, that's a good reason
that's like
not to have
minimum level, right? Yeah, totally.
And talking about lint, you mentioned about compiled languages, and there are definitely a million rules that a million warnings that you can turn on in your C++ compiler, some of which are a little bit a bridge too far because they are very, very opinionated about certain things. But there are definitely linters that are useful to have run on your code as well. There is clang tidy, which I always get confused between clang format and clang tidy because they both sound like they would basically do the same thing. But there are a number of things that can do, static analysis that can do. There are a number of commercial products as well. And the thing about these is this is where it becomes more subjective, very much. Like you can definitely say, like, it's not the compiler's job to tell you that you shouldn't have a naked new. This is like an unmanaged new that's not being held by a smart pointer. So you're basically promising that I'm going to write the code to clean up this object afterwards, I promise. And that's a completely reasonable thing. It's been allowed since the big dawn of the language. Very, very occasionally, it's what you want to do nowadays. It definitely should not be the compiler's position to tell you that you can't do that, is my opinion. But I think a linter could reasonably say, under no circumstances should you use a naked new anymore. You should always use one of the managed things, a smart, share pointer, unique pointer. In fact, always a unique pointer, never a share pointer. But that's a whole other talk. And then you can maybe elect to turn it off. But it's not really. I don't believe morally that's a compiler's job. It's a style thing. And this is certainly what the clang tidy way has moved. There's a lot of companies have published their own guidelines. There's Google guidelines, and then there's the LLVM's own projects guidelines, and these are enshrined in rules that are inside of clang tidy. So a lot of those do say, you can't name this thing this way, or you can't use this idiom of the language. It's just not, don't do it. It's widely accepted to have been a mistake, and we can't take it out of the language because of the way C++ is.
Yes, but please don't.
Probably you didn't mean to do this, and obviously you can turn it off. So I just wanted to make a bit of a stronger case for the fact that I think linting and static code analysis, these are great safety nets to have around. Let's just assume the programmer is a hostile witness. Make sure that we have tests for any changes they might make. Make sure that we have styles, guidelines that are enforced, and make sure that every kind of thing that we can analyze can be thrown at them. And then I think it gives you a lot more confidence to make changes, which is a nice thing, nice property.
There is a trade-off there, by the way, with basically build times or just deployment times,
Interesting point.
Where, all these static checks take time. Sometimes they're pretty fast, but sometimes they can take a long time. And you do have to kind of make a little bit of a trade-off between cycle time and the sort of safety or correctness or formatting or other checks that you get, putting those things in place. I mean, I think the ideal world is that you have, and we've been messing around with this a little bit recently, but you have a pre-commit hook that just does all of these things for you, so it's impossible to check in code. I think I got to get on my soapbox for just a minute.
All right.
I think
I'm just getting comfortable. Go.
Yep. Get a cup of tea, lay back. So I think that the software development world lost something when we started building CI tools, because in the very, very early days of CI, the way it worked was there was a machine that was the CI machine, and you either copied your code over there, or you walked over there with a floppy disk. Like you took your code over to the machine, and you integrated your code on that machine, and then when it was all integrated and the tests were all passing, then you would leave it, and when people wanted to update, they would go to the machine and they would get the latest version of the code, and they would pull it back. Now, obviously, that's a really slow process. I'm not actually suggesting that anyone does that, but one of the benefits of that was that it was basically impossible to share code with other people that wasn't correct. What we have now with basically every single CI system that I've ever seen is you share the code and then the checks run, right? Now, it could be that you're sharing it on a branch, right? Which makes it a little better. But the model is still the same, right? And you still have that moment when you take the branch and you merge it into master, and then you find out whether or not it's correct.
I think what you're sort of alluding to really is that sort of intersubjectivity. It's like if you can't develop confidence that your code works intersubjectively without first checking it in and saying, hey, the first person who's going to find out is the CI machine. Oh, and anyone else who types git pull at the same time.
Exactly. Right. Yep.
Then you've got a problem. Right.
Yep.
Right. That's interesting.
And I fully grant that the way that this problem was being solved before was with a really horrible lock that people would hold for hours. Right. So
while
it's like
they actually integrate.
While they integrated. So it's not like it was better, but there was this dimension of it that was lost where it was like, you know, I in an ideal world, what I would want to do is not have any CI at all. What I want is a completely hermetically sealed, infinitely fast pre-commit hook.
Not much
that you could run. Yes, I know, right? I'm not asking for much here. That you could run on any developer machine, and it would be completely intersubjective, would not depend on the environment at all, and it would give you extraordinarily high confidence that the code met all the, the testing and the linting and all the other things, such that it was impossible to commit code that was incorrect.
Yep.
And then you just push, and then there is no CI because you have high confidence that the commits themselves can't be wrong.
Yeah,
right?
You've proven a different level, and it's a distributed proof as well, which means that computational stuff. You haven't got the single bottleneck and all that kind of stuff. That's really interesting.
Yeah. You can kind of do this with server-side pre-commit hooks, but GitHub in particular,
of like 5 seconds to do it.
Yeah,
right?
GitHub has a timeout on them. If you run your own Git server, you of course can do this.
Yeah,
and I have done that actually.
Oh, interesting.
There was a small project where I actually it was kind of like a little bit of an experiment, but basically like the production deployment server and my Git repository were all the same thing, and I backed them up accordingly. And so you would push to the server, it would run the build in a pre-commit hook that took as long as it took, it didn't really matter, and then just deployed right onto that machine, restarted the services, and did all that. And like that was my only repository. So it was sort of like the Heroku style Git deployment, except the production server was also the Git repo.
Interesting.
And I would take frequent backups and snapshots of that, and that was it. That was all I had. Again, I'm not recommending that as a
but it was an experiment for doing. Yeah, no, I get it.
It gave me this property, which was like, you can't share code that isn't both correct and in production.
Right. So that's an interesting one. I guess you alluded to this earlier about the branch, but enabling requirements of PR in say something like GitHub. That gives you some of that ability. You are still using the fact that you're pushing it to some other place as a sort of intersubjective test. Then you get it reviewed, and then if you don't allow merges without the passing of a CI, then you've kind of reclaimed that. But I think probably what you're alluding to is something that we've seen at work a bit, which is that if your tests take too long or are too hard to run locally, it can be quite easy to start using a pull request as a crutch for maybe just can someone else run my tests for me? Right. And that's not necessarily a bad thing if you've got other things to be getting on with. If you're like, okay, my tests take 15 minutes because there are a whole bunch of really complicated integration tests and I want to move on to the next thing. So I'm going to push it to a branch and then I'm going to move myself to a different branch and go on, and my machine is not bogged down running these complicated things. But I think, it's sort of obviously it would be much nicer if you had your infinitely fast pre-commit hook to run all of these integration tests, and you wouldn't have to think about that kind of thing. You wouldn't have to context switch so much. Yeah,
I definitely, this is maybe just a thing for me, but I definitely have this sort of like idealistic mode that I have experienced in like brief moments, and I never let go of it. And I'm always kind of like, all of the tools and all of the techniques that I wind up seeing, I'm always sort of comparing to this sort of platonic ideal of, infinitely fast feedback loops and all of these other things. And I'm like, yeah, okay, I kind of get why we need to do this. But let's never lose sight of the fact that it's not what we really want.
What we really want. That's a... Yeah. Gosh. One day I'll get you working on some C++ with me, and then you'll suffer for the.
I've done a little bit of that.
You
but
have.
I
have.
Yeah,
yeah,
I have.
It's a different world.
that's definitely a world where I'm just like, man, there's a pretty big gap.
Got to be a better way of doing this, right? Yeah.
Yeah.
So our original goal and topic was linters. We covered a little bit of C++ and some Python. Have you ever had an experience of other languages, JavaScript or
I've used some JavaScript linters. I've used some Java linters. I definitely, it's the same sort of philosophy, but I am definitely in the camp of always turn on all the compiler warnings and then just do whatever they say. One of the things that I wanted to ask you is whether or not you had ever run across any domain-specific linters.
So Clang Tidy essentially has some of that built in. So you could consider like Google's style guide as being a domain specific, and the LLVM code base style guide is domain specific. Now I know also there are things like MISRA C, which are standards for the automotive industry that say you just can't do these things in the language, right? Yeah. This is not allowed. You can't ever do this. This is not, those kinds of level of things. And I believe that there are rule sets for those, and if not, I believe there are commercial tools that will basically run over your code and tell you, you did something that is just disallowed by MISRA. You downcast a 32-bit value into a 16-bit value without checking to see if it was truncated. Those are the kinds of things that you might want to say reasonably is not a good idea.
Yeah.
There are also, an interesting sort of corollary to that is there are now something called the guideline support. Sorry, the C++ guidelines, which are sort of a semi-norm. No, it's non-normative. It's not part of the standard, but some of the people that are heavily involved in the standard are behind it. Some of the sort of big names of C++, and they've kind of sounded like these are definitely rules that we think you should follow, right? And you basically do this by default. You have to have a reason to not do things this way. There are Clang Tidy rules for those as well, right? To say please turn on all the GSLs that you can find. Sorry, GSL is the name of the guideline support library. And they've published a library that says, this is a way of casting a number from 32 bits to 16 bits, and we will throw an exception if it does fall outside of the bounds of what can be represented in a 16-bit number. And the linter is in cahoots with the library and will say, if you are doing this through that function, that's fine, because I know that it's covered. But otherwise, I'll say, no, you can't just assign this value here. And of course, C++ has always been very lackadaisical or very relaxed about you passing, 12 into a function that wants a char. And you're like, well, okay, I can see that 12 is not going to overflow a char. But in general, 12 is an integer, and an integer is probably bigger than 8 bits. And so the char could overflow, and maybe I should be checking that. Now, obviously, the thing about C++ is that you want performance as well. So sometimes you want to be able to say, no, I'm doing this on purpose, and I'm promising Scout's honor that this won't happen at runtime. And so you have to use a different version, which again tells the linter, look, I'm doing this on purpose. It kind of bakes in the linter rule that says, no, this is fine. And so that's an interesting thing, right? You're using a language to almost build a DSL of like, these are things that I'm telling you on purpose that the language has always been fine with. And it sort of almost builds on something. Now I'm going to go off on one here, but builds on something that when C++ came around, you remember C casts, where you just put something in parens and say like, this is an int. You do paren int x, and it's like, hey, there you go. It's now it's an integer. And the problem with that is that you can cast pretty much any single thing to any other single thing. And the same operation was used to say, no, this is an integer and I want to pass it as a floating point value on purpose. Or this is a pointer to void, which is just like a random address, and I'm going to cast it to some really complicated structure with behavior, like an actual object's instance type. You're like, wait a second, those are two very different operations. One is just reinterpret the data, not reinterpret, like actually do a conversion. I know that an instruction is going to run that's going to turn an int into a float. Another one is like, just tell the compiler internally, by the way, just treat this memory address as if it's containing a completely different type of object. And when C++ came in and with the sort of like complicated virtual hierarchies of objects, as you were casting backwards and forwards between, say, objects that were in a hierarchy, an ISA hierarchy, then potentially there were some fix-ups that were needed to be done. Like, hey, this is, don't use multiple inheritance, but if you did use multiple inheritance and you were casting up and down to the two different base classes, potentially things needed to be fixed up. And so that same parens cast is now going, it's not actually a Bob, it's an Ian, and now I need to add 16 to like the address of it. So there's an add hidden in there as well.
Yeah.
The problem with the C-style cast is that it would use whatever information it had at the time to do the best effort of what it thought it was. So if it didn't know that Bob and Ian were actually related in any way because it only seen the declaration of Bob and the declaration of Ian, it would just go, fine, they're the same thing, fine, you told me this. But if if it had seen the class definitions that says, oh, they both inherit from two different, somewhere up on the further up in the hierarchy, then it would do some work. So this is a very long sidebar.
No, this is good. This is good.
So when C++ came along later on in the sort of like the C++, I just say when this was actually I will make no bones about when this came along, but very early on in my experience of C++, there were these new style casts: static _ cast, dynamic _ cast, reinterpret _ cast, and const _ cast. They have different powers. And so if you did a static cast, you're saying, I know these are related types. You can do a conversion from one to the other using knowledge. Like that will allow me to go from an int to a float to an int. It will allow me to go from Ian to Bob if the compiler knows that they have got an inherited base class. It would be an error if it didn't. It would say, like, I don't know that these are related. And so therefore it would stop.
Yeah.
And so those kind of things, they look like function calls, static _ cast, template parameters, the thing. And so all the way back to the beginning now, the GSL things that are like, hey, narrow cast or narrow look like the built-in types in the language. They're just a function call that does this for him. So there's kind of a precedent for it, I suppose, is where I'm going with this.
Interesting. So we need to build, what you're saying is we need to build a custom linter that can check for these kinds of relationships between Bob and Ian, and we should call it cahoots. Because then it'd be like, you can't cast that to this. It's like, no, fine, but Bob and Ian are in cahoots.
Right. That's like, that's that is kind of what the static cast is doing, rather unfortunate. But yeah, it's a funny old world. Yeah, in cahoots.
It's right there.
I think
cahoots.config. It's right. Line 7. They're right there.
Well, I guess that's linters thoroughly talked about, and code formatting and
code formatting,
random C++.
Yes, and rants about how CI used to be back in the 19th century.
I was going to say, my earliest experience with CI was a CI server I wrote myself in Python, very early versions of Python. And I actually came across the code the other day. It was hilarious to look through it and have a laugh. But one thing I'd forgotten that I was reminded by that is that I had bought one of these, an outlet that I could control programmatically through the serial port on the CI machine. And I had a green lava lamp that was on when the build was green. And then I had a red spinning, like actual disco, like a police thing for when it went red. Which was a great idea. I had a great fun, learning how to get the protocol to work over the serial cable to get to talk to this funny device and putting it in there. And as you might have guessed, the red spinning light lasted about 3 minutes before it was unplugged and removed.
Yep, that's right.
Because it's
I think I even have. Do I have? Oh, I have.
All right. Okay. All right. I'm amusing myself here as Ben, unseen, is rushed off into the background to his shelving and has come back with drum roll.
Exactly what this is.
Oh my gosh, we are the same person, Ben.
Here's the cable, the USB B cable. Here's the power supply.
Orange
here's the
flashing light there,
little on-off switch.
That's amazing.
It does exactly the same thing. This is this two's compliment, man.
That's what it's all about.
Branched back. We've branched apart, came right back together.
We're in cahoots.
We're in cahoots.
All right, my friend. Well, we better stop there because I don't think we can top that.
Yeah.
I'll see you next time, my friend.
Yep. See you later.
You've been listening to Two's Complement, a programming podcast by Ben Rady and Matt Godbold. Find the show transcript and notes at twoscomplement.org. Contact us on Twitter at 2CP, that's at TWOSCP.
Theme music by Inverse Phase, inversephase.com.